Welcome back to Linux Fundamentals, Module 006. This is the module where your fingers stop fumbling. In Module 005, you learn to read files with cat, head, tail, and to delete them with rm. In Module 006, we add the other half of the daily toolkit. Copy with cp, move and rename with mv, decode the full ls-l output, work with environment variables like home and path, match many files at once with wildcards, master the 3 porting styles the LPR exam loves, and finish with keyboard shortcuts that double your speed. 6 pieces, 1 rule from Module 5C applies. Type every command yourself. Watching me will not move your fingers. By the end, you'll handle the daily file work with junior cloud engineer in a Lagos fintech or at MTN, Cameroon, Rwanda, or Ghana without breaking sweat. Why this matters in real life? Every cloud server you ever touch in any cloud platform, AWS, Google Cloud Platform, Azure, Oracle, or DigitalOcean, is a file tree you manage from a keyboard. These are the verbs of that job. Quick recap from Module 005 before we open today's chapter. 5 things you already feel automatic. Lowercase file names, no spaces, monthly underscore report.txt and not monthly space report.txt. Sudo is your VIP pass and main power for one command, then you drop back. Echo prints text and variables. Cat reads small files. Man opens the manual. rm deletes permanently. rm-i acts first. Tap is the number 1 shortcut. Sudo bang bang the number 2. Quick check before continuing. Which command from Module 005 watches a locked file as new lines are written? Try to answer that before reading on. The answer is tail -f. Today build straight on top of these. We'll copy and move what we can already create and unlock environment variables to make echo dramatically more useful. Walk through the objectives. These are what the assessment will test, and they all map directly to LPI Essentials exam topics. By the end of this module, you will copy files and folders with CP, including CP-R for directories. Copy and move from one directory to another. Move and rename with MV. Decode every column of ls-l, file type, permissions, owner, group, size, date, name. Use wildcards, star, and question mark to operate on many files at once. Read and create environment variables, including path and home. And master the 3 porting styles, double quotes, single quotes, and backslash, which is one of the most frequently tested topics. Pay particular attention to the quoting slide. Covers 2 to 3 exam questions on every attempt. When you SSH into a production server in Frankfurt or London and need to copy yesterday's logs to a backup folder, every verb on this list is in the command you type. Part 1. File operations, cp-nv. The 2 commands that do the actual day-to-day file work after you have created and read them in Module 5. cp duplicates, nv moves and renames. We'll cover all 2 in this part, and then in part 2 break into ls-l, environment variables, wildcards, and quoting. cp, the verb is copy. It makes a duplicate. The original stays exactly where it was. Walk through the terminal block on the right. Line 1, copy report.txt, report underscore backup.txt in the same directory. Line 2, copy a file into another folder. Line 3, wildcards in action. Style.txt copies every .txt file at once into docs/. We'll go deeper on wildcards in part 2, but this is the preview. The critical rule is in red on the slide. To copy a directory, you must add the -r option. Without -r, cp refuses point blank. Last line shows -rv, where v is for verbose mode, It prints every file as it copies. This is useful when copying hundreds of files and you want to watch progress. An analogy: TP is a photocopier at a Kigali print shop or in Bamenda. A single page goes through fine, but to copy a whole binder, that is a directory, you flip the machine to binder mode. That switch is -R. Time for a quick demo to see what we have just covered. So let me go back to the terminal. And on the terminal, I'll start first by creating some of the files that we need. So I'm going to do touch report.txt. Touch command creates a file if it doesn't exist. So if I do touch report.txt and hit enter and do an ls, I'll be able to see that a file called report.txt has been created. I also want to create a directory called docs. I'll need that directory. So the mk always create a directory. In Windows, you will say folder most of the time. In Linux, you mostly say directory. So make directory docs will create a folder or a directory called docs. If I do ls, I see that there's a folder docs and I have also the file report.txt. Now, let's go ahead and use the commands. I'm going to first start with using the copy command, and I'm going to use report. I want to copy the file report.txt. Remember, the copy command creates an exact copy, and the original copy or the original file stays where it was. It doesn't change. I just create a copy of it, right? It's like making a photocopy of a page. The original page is there, but then you get a copy. I'm going to call this new copy I'm making report_backup.txt. If I hit enter, it completes. It's always good to look at what you have typed before you hit enter. I do an ls. I see that I still have the file report.txt here, but I have now another new file called report_backup.txt. So that's how I can create an exact copy of a file, and the new one will still remain in place, right? So that's the first command. That's copying in the same directory, right? Everything is staying in the same directory. What happens if I want to copy report.txt inside docs itself? So I want to copy from this current directory. Remember, pwd shows that our current directory is /home/ubuntu. All the files we see here are sitting inside /home/ubuntu. But what happens if I want to copy this file to this directory? So I can use the command copy report.txt, and I'll say take that file and put the copy inside docs. That's the absolute path here. Remember when we said absolute path, it always starts with the / of docs directory. So I'm asking it to copy this file and place that copy inside the docs directory, inside here. So let's do that. I hit enter. And if I do ls of /home, right, /home/ubuntu, I want to see what's inside docs. I see that there's a file inside called report.txt. That is the file I've just copied into that directory, right? So those are the two commands of how to copy a file. This one copies, we're in the same directory. This one is going to copy into another directory, and this time the docs directory. Okay, so let's continue, and also I'm going to clear the screen. I hope this is clear for now. I'm going to create another file, but this time I'm going to use the echo command, and I'm going to say sales for 2016. I want to put this content inside a file called original.txt, right? And if I hit enter and do an ls, I should see a file called original.txt. Remember, we used the echo command to create a file, and the content sales 2026 is inside original.txt. As a review, I can cut that file. Let me say do original.txt. Let's see what's inside sales 2026, right? So as a review of the cut command, but we're interested in doing a copy. So what I can do is I can also do copy original.txt, and I say copy.txt is going to duplicate txt. If I hit enter and I do an ls, I'll see that there's a new file called copy.txt, right? And if I look at the content of this file, so let's do cut on copy.txt. What is inside that file? Sales 2026. I created a file called original.txt using the echo command, and I did put sales 2026 as input to that file. I confirmed by doing cut original.txt, I could read that sales 2026 is inside this file here. I made a copy of original.txt to copy.txt, and when I do cut on copy.txt, I see that it contains the exact content that is original.txt, right? So that is how you can copy a file. Now, let's try to use the star. Remember, we did say that star means everything. So what we're going to do is we're going to copy all the files. I'm going to do ls. If I do ls, I see that there are many files. I have notes here.txt, a.txt, copy.txt. Let's say I want to copy all files ending with .txt inside the docs folder. I want to copy all of them inside the docs folder, right? So I'm going to do copy star.txt, right? So star here means everything, .txt, anything, a letter, a word, file, everything. Star just means everything, right? Everything.txt, any file that ends with .txt. Say any file ending with .txt, I want to copy it inside docs. Another way of specifying the docs folder is just because it's sitting in the current working directory, I can just say docs and then I hit enter. It completes successfully. Now, if I go ahead to look at ls and I say ls docs and I hit enter and want to see what's inside the docs directory, it will tell me that these are all the files present. So you notice that the files that are in the working directory, we are in the current directory. If I do pwd, is home/Ubuntu. If I do ls, I see that it has the files notes, right? This is the capital txt. You notice this has not been copied, but notes.txt. So let me repeat and do ls docs, right? ls docs contain now the files notes.txt, which is this one, b.txt, right? It is present in docs, and if you notice very well, b.txt is also present in the home directory. So all the files that were in the home directory that ended with .txt, the small letters have been copied to docs. So that is how you can copy many files at once by using the star command. That was star in action. Now, let's look at the folder test1, right? I want to look what is inside test1. Let's look inside that folder. Empty, right? I have a folder here called test1, right? ls test1 is empty. Nothing is in it. There's a reason I'm showing it. I want us to use the -rv options. -r is recursive, v is verbose. So let's say I want to copy all the files -rv, right? I want to copy all the files that are present in docs, and any file that is ending with .txt. How do we do that? I use the star command, .txt, right? I want to copy, that's a .txt. I want to copy all those files to test1 directory. So I'm going to do test1 / So I want to copy all those files inside the test1 directory, right? So I'm going to explain the command again. Copy, I've used -R and V option. I want to copy all files that are ending with .txt that are inside the docs directory. Remember, we just look at the docs directory up here, right? When we did this is the docs, this is docs, we just did ls docs and we noticed that it has all these files. So I want to copy all these files to the test directory. So I'm going to, but I want to see how copying is happening. But remember that verbose means seeing how everything is happening or how everything is progressing. So if I hit enter, I will notice that it will be telling me docs/notes.txt has been copied to test1/notes.txt. Docs/a.txt has been copied to test1 a.txt. B has been copy.txt. So all the files that are in docs that end with star.txt have been copied to test1 directory. And I can see that because I use the -V option. It is reporting to me as it is progressing, right? So if you want to view the copying as it's progressing, you can use the V option, right? So if I do now an ls on test1, remember earlier on that we did an ls on test1 and it was empty. If I do an ls now on test1 and hit enter, I see that I also have copies of the .txt files inside test1. Okay. Now, that is how to copy files. Let's move on to copying directories. And for that, I want to clear the screen and let's look at how it works. Let's do an ls. Let's look at what we have. We have the docs and we have photos test1. Which directory should we use? So let's try to first of all do it the wrong way. Let's say I want to copy the contents that are in test1. I want to copy this directory into photos, right? Let's say I want to copy this directory test1 into the directory, let's be projects. Projects look much better. But before that, let me look what's in projects. Projects have another directory API, just a test directory, so nothing to worry. So let's say I want to copy the entire test1 directory. And what happens, I just do test1 and I say copy the projects. I want to copy that to projects. Hit enter, notice the error message. -R not specified, omitting directory test1. If you remember, I did say that to copy a directory, you must use the -R option. So when you see this error message, or when you always get -R not specified when copying a directory, it means you didn't specify it. So let me do it now correctly by using the -R option. And I say copy test1 into projects. And I hit enter. It completes now successfully. If I do now an ls of projects directory, let's see what we get. I see that the directory test1 is now inside. Just remember that moments ago, I did ls projects and it gave me just API. I tried to copy the test1 projects into the projects directory without the -R. It complained with an error. I did correct that by using the -R. Now copied successfully, right? So that is how the -R flag works. And that's why you should use it when you are copying a directory. Now, why does copying matters in real life? And I want to show you in regards to a file. Before any change to your configuration file, for example, you mean configuring the GINX, right? GINX is a web server. If you are configuring the file, the way you should ensure that if you make an error and you want to come back to the original file, you should always make sure you create a backup copy of your file. So how do you create a backup copy of your file? You do copy, this is the original file. The original file of the GIMS configuration is /it is found, which is always found in /etc/GIMS /GIMS.conf here. I create a copy of it and I say keep that file. Right, I'm going to call it. You always see backup. So before you start editing any file, it's always, especially configuration files, it's always good to create a backup copy, such that if you make a terrible mistake on the original file, you can always go back to the original copy and have what was present, right? So the backup file that you always have is your undo button, right? So if you want to undo something, the only way is, do you have a backup copy, right? You are going to meet this when we start doing the configuration in Module 9, where we'll configure the GIMS server. But for now, keep in mind that this is how you can keep a backup copy of a file. You do a copy of it, and then you edit the original. And if you make a mistake, you can restore what you copied before. Now, I know most of you in trying to do this demo, you may want to create files and folders to have exact names that I have in the demos. You can also create your own files with different names and apply the same commands. Yeah, you have to be creative as well. But I do understand that at the beginning, that's what you may be tempted to do, but just grow from it, try to be creative and create as many files with different names as you can. So let's return back to the slides and see what we have to do going forward. The next command we need to look to is the mv command. Mv does two jobs in one verb: move and rename. Same command, the difference is just where you point it. Run mv file.txt new name.txt in the same directory and it renames the file. Linux has no separate rename command. This is just it. Now, if you run mv file.txt /homes/ubuntu/docs/, it will move the file to that directory docs. You can also combine move draft.txt docs/final_report.txt and it will move the file and rename it at the same time. Unlike CP, mv does not need -r for directories. Just point it at the folder or directory and it moves the whole tree. The CP versus mv block at the bottom is what you have to remember. CP is a photocopy, original states. mv is delivery from Juma or Amazon. The package leaves the warehouse and arrives at your door. It's no longer in the warehouse. Now, time for another demo. So let me go back to the terminal and let's see what we can do, right? This is what I had earlier on. I'm just going to clear the screen and I'll start by creating a file called touchallname.txt, right? Let me create a file with name allname.txt. And if I do nv, remember allname.txt, and I give it new, I point it to new name.txt. If I hit this command, but before I do that, just one thing, I just want that we are clear on what we're doing. I did touch allname.txt. If I do an ls, I notice that there's a file called allname.txt, right? I used the touch command and I created the file allname.txt. Now let me go ahead and do mv on allname.txt and I point that to a new name.txt. If I hit enter, let's see what happens. The move command renames this file. It was allname.txt. The file is now new name.txt. That's how you can rename a file, right? So if you have a file and it had a certain old name, you can rename it by using the move command, right? So let's do some other combinations and more examples as this will become clear. This has happened in the same directory. But what happens if I decide to do something like move? I have a file here, original.txt. Let's say I decide to point the move command, and I say home/ubuntu/backup, right? I have a folder also called backup here. If I type mv original.txt and I point that to a complete folder here, what happens? If I hit enter, if I do an ls, the first thing I notice is that I no longer have the original.txt present, right? Remember, I did ls here. I was able to see original.txt. I did mv original.txt, and I pointed that to the backup. So let's look at backup. What is inside backup now? Ls backup. I see that it has moved original.txt. That's the analogy we were using when you buy something from, when you have a delivery, say from Amazon or Jumia. It leaves the warehouse, it's no longer there, and it goes to the new location. So when you use move and you point it to a directory, it takes the file and move it to that new directory. Remember, this is completely different from copy, where copy creates another copy of the file, but the original stays in its location. Move actually move the file from one location to another. Okay. We can also combine move and rename in one command. So let's say I have this file here, move copy.txt. I want to move this file to projects, but I want that when it arrives projects, it should have a new name, say final copy.txt. How will I do that? All I need to do is to use the move command. I do copy.txt, and I'm going to point that to projects. I'm going to use relative absolute part, relative part here. I'm not using the forward slash. So I'm going to point that to projects. And when I hit enter, the first thing I do ls, I notice the file copy no longer exists. I did move copy.txt. If I do ls projects, what do I have? I see copy.txt is present. But actually what I want to do is I want to rename the file when I'm copying. So let's pick a different file. I'm going to pick this file. Let's say report.txt. I'm going to move it inside projects, but I will give it a name, final report. So let me say I'm moving report.txt. I want that to go inside projects. And I want that when it goes to projects, it should have a new name called final_report.txt. So I've specified the new name. If I hit enter and I do an ls, the first thing is that, remember there was report.txt. I no longer see report.txt. It has been moved. And if I go inside projects, let's see what we'll get inside projects. If I do a listing of what's inside projects, I'll see that there's a new file, final_report.txt. So that's how you can combine both commands at the same time, right? I'm going to clear the screen and I'm going to use a combination of commands just to show you other ways in which you can execute some of the things that we have done, but using just one line, right? I've been doing copy, I've been moving, and then I'll do ls. But what happens if I want to do all of that just using one command? So I'm going to start with, let's say I want to use the echo command and create the file called draft.txt, right? It's going to create the file draft.txt, and the content inside draft.txt is going to be hello. And immediately that is done, I want it to be immediately display the listing so that I confirm that draft.txt exists, right? Or draft is too basic. Let me just use something like sample.txt. I'm creating a file with the word hello inside, and I've called the file sample.txt. And I want that in one command, it creates and then it gives an ls so I confirm the file exists. So if I hit enter, I immediately see that there's a file here called sample.txt, right? Instead of using two commands where I do hello, echo hello, sample.txt, hit enter, and then I come back and I do ls, I use the double and sign here, which means it should do an ls that it creates this file, right? Let's use again more of such. I'm going to say move sample.txt. I'm going to move that file, and I'm going to say move into final sample.txt, right? And I want that it should give me an ls. So what's going to happen? It's going to rename sample.txt to a new name, final sample.txt, right? Remember, if I use move sample.txt and I point to the same name in the same directory, it renames a file. So let's hit enter and see what happens. I notice now that I have final underscore sample.txt. The original file sample.txt no longer exists. Okay, right. Let's proceed and say I want to make a directory for archive. And what am I going to do? I want to move the file right now sample.txt. I want to move that file to archive, right? So here are many things that are happening. I'm creating the directory archive, and then I'm moving the file final underscore sample.txt to archive. And immediately after that, I want that it should show me that the file, it should show me the current listing so that I confirm that final underscore sample.txt no longer exists. So if I hit enter, I can see that I don't see the file final underscore. Notice you have final underscore sample.txt. That file no longer exists here. Where should it be? Remember that this command created an archive directory and it moved the file into that archive directory. So if I do an ls on archive and hit enter, I see that the file was actually moved inside that directory, right? So here was just a combination of shortcuts to show you how you can quickly move. Why does this matter in real life? When you are going to start deploying code, especially in productions servers, you realize that the standard pattern is to upload to a directory called /10, and then you do some testing, and when you finish, you can always then move it to, let's say you run the move command. Let's say you had an app, you actually had it in 10, something like this. After it was present in a directory here. So after finishing testing, you notice that you will just move it to a new location where it will see. So move is kind of atomic on the same file system. The file appears as its new path instantly, and there are no half state for users to see, right? Now, if you're working with this command and you get an error message like cannot start sample.txt, no such file or directory, it means the source file does not exist in the current directory, and you can start by running an ls. So for example, if I did say move draft.txt to o underscore draft.txt, if I hit enter, I'll get an error message, cannot start draft.txt, no such file or directory exists, because I didn't, if I do an ls, there's no file called draft.txt. So make sure that you have the file existing before you start moving it. Before you start renaming, in this case, renaming it, you cannot rename something that doesn't exist. right? So that is what I have. Let's go back to the slides and see what to do. All right, moving on. Let's look at part one closing slide, ls minus l, the long listing. This is a very loaded slide, and I want you to take full attention and actually spend some time to have a full understanding of ls minus l. For module 004, you use plain ls. Now we decode the full output. We're going to walk row by row through the diagram on the screen. The example line has 7 columns. Column 1 is file type plus permissions. The very first character tells you the file type. Dash means regular file. D means directory. L means symbolic link. C is character device. B is block device. Column 2, the hard link count. Column 3 is owner, while column 4 for the group. In column 5, that will be size in bytes. You can add -h on the ls minus l listing so that you have human readable like kilobytes, megabytes, and gigabytes. Column 6 is the last modified date and time. Column 7 is the file name. The permissions block 9 characters after the type letter split into 3 groups of 3: owner, group, and others. R is read, W is write, X is for execute. Now let's do a quick demo here, and I'm going to go back to the shell, right? So I'm going to do an ls minus lh, h is for human readable, /var /log, right? We're going to get a full interpretation of the output. So I'm going to hit enter. And when you hit enter and move right at the top here, the very first thing you see is total 3.0 megabytes, right? This is the total disk blocks used by all files listed. It is not the number of files, it's the storage space consumed by all the files that have been listed here. So all the files from the top here, all of them consume 3.0 megabytes. That's the very first thing you should know. Now, the next 10 characters, and in this case, these ones here, you have L and you have RWX, RWX. So the very first character, the L, we have said the first character represents the file type, right? If you go back to the slide, remember L represents the first character represents the file type. So in this case, we have L. The file type L is for symbolic link. This character could have been a dash, which will mean a regular file. So if I go back, we'll see that there are some files that have just a dash. So dash here means a regular file, and D, based on what we have seen, will mean it's a directory, and you can see this is a directory. So if I go again back on the slides, dash means regular file, D will be for directory, that's the very first character, C for character device, B for block device. And in the very first file that we have here, we have an L, which means this is a symbolic link. We'll learn more about symbolic link later, right? Then we have the 3 groups here, where the very first group, the RWX, means the owner. These are set of permissions, right? R is read, W is write, X is execute. The very first set of permissions, group of permissions, read, write, X belong to the owner or user. The next set of permissions, RWX, belongs to the group. And the next set of permissions belong to other, everyone else, right? So these permissions can always alter. And here is the interpretation of what read means when it's on a file and what read means when it is on a directory. What you should take note is the X here, which means execute if it's on a file. And if it's on a directory, it means you can be able to use the command cd and enter into that directory. So if you have a directory without the X permissions, you cannot be able to change to that directory, right? So if I go back to our shell, you notice that almost every directory has the execute for others, right? Every directory has at least the execute because it means that you can be able to change to that directory. So let's continue to decode the entire output. And what I want us to look now is column 2. So we have just dealt with column 1, which has 10 characters. So column 2, which we have the number 1 here, it is 1. This tells you how many directory entry points that file's data, right? For a regular file, it is usually 1. For directories, most of the time, it's mostly 2, or you can find more, right? So if you notice, directories will always have at least 2, but for regular file, that would be 1. So think of it as for directories, it's 2. That's good to see. Now, the next column will tell you the user or whoever owns the file, right? So we are on column 3 here. It's telling you who owns the file that we have. So here, root owns the file. Now we're looking at /var/log, and most files in /var/log are owned by the root because the system itself writes on them. On your EC2 lab, files you create will show Ubuntu here. So you notice that when you create files and you do an ls listing, they will show that the owner is Ubuntu, right? Now, the next group, the next column, which is this one here, is the group that owns this file. Linux allows a group of users to share access. So the group permission applies to anyone in this group. So think of it as a WhatsApp group. If you are in the sysadmin group, you get group level access, right? The next one is the file size. And here we have 39. We have 39 here. So this is the size of the file in bytes by default. And when you want to see human readable form, we have, that's when you do the minus, the H here. Right? You'll be able to get it in kilobytes, megabytes, or gigabytes in some cases. Now, column 6 will represent the last modified timestamp. So this entire, you have here August 10, 11, 35. So column 6 is last modified timestamp. This is when the file was last modified. If the file is older than 6 months, Linux will just show the year instead of the time. And then column 7, which is now this one here, represents the file name. And if it's a symbolic link, it will also show the link target. So like in this case here, we have a file name, but here we also have the link target. We're going to learn about symbolic link later. So that is the entire our interpretation or how we can decode that output of ls-l. I have a summary here on the screen. So on the slides here. So this is a full summary as well. File type plus permission, the very first 10 characters. So take note of that. The very first 10 characters here is the file type plus permissions. So always remember that this first character, if you see a dash, that's a regular file. If you see a D, it means it's a directory, what you have. Then the next 9 is a set of permissions. L here is a hard link count. And root here is just telling you who is the owner of the file, right? And the next one is the group owner, size in bytes, the last modified date and time, then file name. Altogether, 7 of them. I think by at the end of this slide, you'll be able to get a full understanding of what that is. Now, continuing, we're going to look into variables, wildcards, and porting. This is the part 2 divider. Environment variables and wildcards. We move from manipulating files to manipulating the shell itself. Environment variables are the system settings. Wildcards are the shell's pattern matching. Quoting tells the shell which characters are special and which are literal. 3 small concepts that together make the difference between a beginner and a professional. The quoting slide especially, that's the LPI heavyweight, this model. So pay a particular attention to that. Environment variables. Every Linux shell carries a set of name values that the system and your programs read to know how to behave. Convention is uppercase names. You read them with a leading $sign. The big 4 to remember are home, your home directory. User, your username. Shell, which shell you are running, usually /bin/bash. Path, the list of directories, the shell searches when you type a command. Now, we're going to go to the terminal and kind of walk through some of these examples. So I'm going to go back to the terminal here. And if you notice, if I do, for example, echo, I will read the value that's inside the variable home. I place the $sign in front of it, right? If I hit enter, I get /home/Ubuntu. If I go ahead and do echo user, I get Ubuntu in this case, right? And if I do echo path, I get a list of directories that are printed, right? To see every environmental variable on the system, you run env or printenv. So if I do env, it will show me all environmental variables that are present in the system. And here I have, you see, notice shell is /bin/bash, pwd /home/ubuntu, home here /home/ubuntu, log name here is Ubuntu as well. So those are the different variables that are present on the system. But let's focus on the variable path, right? Again, I'm going to do echo path. Why does this matter? Why is path important? This variable prints a list of directories that are separated by a column here. This is the first directory. This is the second directory, right? Now, when you type a command like ls, the shell does not magically know exactly where ls lives. If you remember, everything in Linux is a file. So even a command like ls or a command like pwd is a file located somewhere in your system. So when you type a command, the shell needs to look for where that file exists before it goes ahead to execute it, right? So if I type ls, for this command to run, the shell will go and look inside each of these directories to figure out where that file actually lives, right? So if you remember, there was a command that we used earlier on. If you do, for example, which ls, it tells you exactly where that command lives. So the ls lives in this. This is the file. It is located in /usr/bin/ls. Just like if I look for the command pwd, I notice it also lives in /usr/bin, and there's a file called pwd. So when I type the command ls, the first thing the shell does is it looks inside these directories, and you notice immediately it comes to the usr/bin, it will find the file ls. And when it finds that file, it goes ahead and then execute it, which is a command, right? So it goes ahead and execute it, and then it's able to execute that command, just like it will be able to execute the command pwd, right? So still back on my shell before we come here. So environment variables are the customer profile. If you are thinking of environment variables, you can think of them as a customer profile saved in your MTN Momo app, your name, your number, and your default language. The app reads them every time without asking, right? This helps you to be able to know exactly, like in this case, the ls will be able to know exactly where that command lives. Now, if you try to do the echo command without capital letters, so if I try to read this without capital letters, or if I make a mistake and mix them, you notice that you have nothing to see in here. So always make sure that the all capital letters really do matter. Why this matters in real life? When you SSH into an EC2 instance for the first time, the very first command most senior engineers will also run is they will always run the command echo user. They just want to make sure that am I the person I think I am, right? As well as run the command echo path This actually gives the engineer the idea to know whether they have all the tools that they require for the work they want to carry. Okay, now moving on, you can also create your own environmental variables. It is very possible to create your own environmental variables, but the rules are tiny and can trip everyone as well. But rule number one is no spaces around equal sign. So for example, my capital letters, my underscore name equal to Grace with no spaces works, but my underscore name equal to space and Grace will fail. So rule two, use uppercase for variables that you keep. Rule three, quote values that contain spaces. Rule four, read with dollar name. So you always have the dollar in front when you want to read the value that's inside any variable. The export keyword, the export key is actually the second most tested concept after quoting. So without export, your variable lives only in the current shell. With export, child processes inherit it, right? Let's try to do a demo for you to understand what that actually means. So let me just go back to the shell terminal here. I'm going to do clear. So let's try to, I'm going to export my town. Let's say I'm creating a variable, my town, and I'm going to call my town Kigali. Moment. And if I hit enter and echo my town, because if I hit enter, I get the value Kigali. And let me open a new shell, which is like a process here. If I open a new shell, I just type bash, it opens a new shell. If I do echo my town, will I get an output? I get nothing, right? So why did this happen? Remember, I needed the export keyword. The export keyword will make it possible for child processes to inherit that the value of the variable I set. So when I just, in this case, I did not use the export keyword here. I created Kigali. I created my town with the value Kigali. So I'm able to access that value as long as I'm still in that shell. But immediately I type bash, bash opens a complete new shell. And if I try to access the value of my town, I will not be able to get it. So let me come out of this shell because bash created a new shell. I'm going to type exit. Exit will take me out from that shell that I got in. And this time I'm going to set that variable using the export keyword. So I will set export town. This time I'm going to use Kigali. I'm using Kigali as my town, right? If I go ahead and do echo my town, here I get Kigali. Let me get now to a new shell by typing bash. If I try to do echo my town, what happens? I'm able to access that value. In the first case, I did not use the export keyword. And when I did open a new shell and I ran echo my town, I got a blank. It's kind of, I could not access that. That variable doesn't exist in this new shell. When I exited the shell, I set now the variable using the export keyword. And when I type echo, when I try to access that variable in the current shell, I can access it. If I go to a new bash and I echo my town the variable, I'm still able to access it, right? So this is very important to keep that in mind. The other thing that you should remember is that variables also disappear on logout. So if I do logout here, if I do logout and start a new shell and come back, I'll not be able to access my town here, right? I can demonstrate that by, let me just go out. So just remember, I have a variable called my underscore town with the value Kigali. So if I exit this, so I did log out. I'm logging in again as Ubuntu. If I try to access that variable I created, it was my town. If I hit enter, get empty space. So the key thing to remember here is when you log out, the variables that you set actually do disappear. If you want to make them permanent, you need to append them into a file called the dot bash rc. So how can I know where that file is? If you notice, there's a file here called dot bash rc, right? So if you want your variables to be permanent, you can go ahead and append them in that file. We're going to see more of that in Module 8, but just keep in mind that variables disappear when you when you log out. Now, what's the importance of variables? Now let's try to look at how to create a variable here. So let me show you how we can create a variable. So let's start by coming back here. I'm going to create a directory called my project. Let's say I have I want to start a project, and I'm going to create a directory called my project that I'll use for this. Then what I want to do is I want that there should be, I want to set a variable for export. I want to set a variable called project directory. Excuse me, there's here. Okay, I'm exporting the project directory, and I'm going to set that to $home, and then it should use project here, right? So I've used the export project underscore directory equal that. And if I hit enter, and then if I go ahead and say I want to cd to change to that directory, I instead access the variable underscore down. If I do cd, then what do I get? You notice I changed directly to my projects, because if I do print working directory, the /home/ubuntu/my project, because I did export project directory to be equivalent to $home. We know $home is equal to /home/ubuntu, and then inside this order of my project. So if I do cd and make sure this entire variable here, the value is going to change to my project. This is very important because every deployment script to production starts by exporting variables. You see that. So variables like database underscore URL or AWS region. And knowing how export works is the difference between a script that will run and one that would likely fail, right? So just keep that in mind. Now back to our slides. All right, moving on. 14. The slide the LPR exam writes its trickiest questions about. There are 3 styles with 3 behaviors. Memorize the difference. Double quotes. Variables are expanded. For example, echo hello $user in double quotes will print hello Ubuntu. Spaces inside the quotes are also preserved as one argument. When you use double quotes, you always use that when you want the variable plus literal text. If you use just single quotes, nothing is expanded. Everything between the quotes is taken absolutely literal. So echo hello space $user with single quotes will print hello $user, $ and all. The backslash escapes one character to its right, making it literal. So if you want to, for example, print price is $5, you need the backslash in front of the dollar inside the double quote, because then this prints price is $5. Right? Think of that when you want to escape character. Time for demo. So I go back to our screen. We're going to do a demo to understand all these concepts. So if I do echo my name is $user in double quotes and I hit enter, what happens is the value that is present in user will be given in the output. So this is expanded. So if I hit enter, I will see echo my name is Ubuntu, right? So echo all of this is expanded because I'm using double quotes. What happens if I use single quotes? That's something different. If I use single quotes and I try to access the value of user, if I hit enter, I get my name is $user. Single quotes makes everything here to be printed literally. Nothing is expanded. If you want the value to be expanded, you use double quotes. So take note of the difference between single and double quotes in this particular example. Now, let's try to do, if you want to do something like echo double sign, double quotes, cost is, I want to get $100, right? So if I go ahead and do something like, let's say I wanted to cost is, if I do something like this, let's say I wanted to say cost is $100, see what will happen. I want to do it the wrong way so that I see it won't work. It just gives me cost is 00, right? Now, it has gone, and we don't know where one has gone, but I'm not so sure what just happened. But I wanted $100 printed. So what do? Remember I said that backslash kind of escapes one character to his right, to the right, making it literal. So if I do echo cost is, I do backslash because I want one character, and that one character is $. This will be printed literally because I'm using backslash. We will skip one character to the right, we will print that literally, and I now have cost is $100. The reason is because $sign is used to access what the content of a variable. And if I'm going to use $sign also, I need to let the shell to not interpret that particular $sign here. And that is why I use the backslash in front of it. Now, if you want to think, now that backslash is used to ask to escape one character to the right, it's the same thing. If I want to ask to type backslash, what am I going to do? If I want to echo backslash, let's say I want to read backslash itself, right? So backslash itself, I will do double backslash here because the first backslash is saying that escape the next backslash and print it literally. And if I hit enter, I'll have just one backslash. So the first one says ignore the next one that is coming, right? Now, these are things that you should really pause and make sure you get a good understanding. These three different concepts I have: a double quotes here, single quotes, and a backslash that is used to escape one character to the right. Now, every shell script you ever read uses all three quoting styles. Get the difference wrong, and you will notice that some of your deployment scripts will actually break silently. Okay, so let's go back to the slide and move on to the next topic, which is keyboard power. Part 3, keyboard power shortcuts, the smallest part of the model and the highest return on investment. No new commands, just keywords that make every other command faster. Beginner style, professionals fly. The difference is in the next slide. You have seen some of this already. Ctrl+C, the command Ctrl+C, stop any running command that you have, right? Ctrl+L, clear your screen. We have seen that same as typing, but it's more instant. Ctrl+A and Ctrl+E jump to the start or end of the current line, right? Ctrl+W deletes the word before the cursor. Ctrl+U deletes the whole line, while Ctrl+K deletes from cursor to the end. Okay. Ctrl+Z suspend a process, pair with B, and then you have pair that normally with BG or FG. We'll cover that in model 9. Ctrl+D ends input or logs out. We have used that in model 5. Ctrl+R searches command history backwards, and you type a few letters, and then you see how that works. Let's just do some demo here to see how some of these commands work. Then you continue practice that. So if I do, for example, sleep 100, it makes the terminal to hang. You notice if I do sleep 100 here, I don't get my terminal back. And if I decide to press Ctrl+C, it breaks that and I'm able to get it back. So Ctrl+C is very, very important when you want to stop anything and get your phone back. So if I type, for example, let me just type everything here as it is. And if I do Ctrl+A, it takes, you notice the cursor comes right at the front of the line. If I do Ctrl+E, it takes me at the end of the line, right? So the cursor, when I press Ctrl+A here, the cursor jumps to the beginning and I can add whatever thing I want. And if I wanted to go, let's say again, at the beginning, I press Ctrl+A, you see, and then now the typing is added right in front. If I want to go at the end, I press Ctrl+E. Ctrl+E, you notice I'm at the end here, and I can also type whatever thing I want, right? So Ctrl+A takes me to the beginning, Ctrl+E takes me right to the end. In some terminals, Ctrl+S freezes the screen, and the way to fix it is to use Ctrl+Q to unfreeze. In a real-world scenario, you can SSH into a Bermuda hosting server. So if you accidentally run -F on a wrong file and it's flooding your screen, what you do is you press Ctrl+C immediately, right? Most senior engineers look fast not because they know more commands, they look fast because their fingers can find Ctrl+A, Ctrl+E, Ctrl+R without their eyes, leaving the screen, right? So practice this often and you also come to be very fast. Okay, so back to the slides. And key takeaways for Model 6 is read each point on the slide before you actually continue here, right? So just the key takeaways I want you to capture. DB copies, you use -R for directories. MV moves and renames in the same verb. No -R is needed. Space, slash, and cure are used when you are kind of navigating any big file, right? When you are using the less command, we saw that earlier on. ls-l shows 7 columns: type, permissions, links, owner, group size, date, and name. Environment variables store system settings. You can create your own with name equal value, no space. Then you can export that to with child processes using this by using the export keyword. Wildcard star and question mark select many files at once. 3 reporting styles exist. Double expands while single is literal. Backslash escapes 1 character. This is a very important area in the LPI exams. Keyboard shortcuts double your speed. Before moving on, ask yourself, what's the difference between echo, hello, $user in double quotes and hello, $user in single quotes? The first one will normally print hello Ubuntu. The second one prints hello $user literally. If that answer came to you immediately, you definitely do on this model now. Do not forget Kimo, your AI learning assistant available right here in the course. If anything from today is still unclear, quoting export wildcards, ls-l columns, ask Kimo to explain it in a different way or quiz you on it. That brings us to the end of Model 006. Before you move on, complete all the remaining model activities, walk through the hands-on lab, answer the knowledge check questions, and attend the certification style questions. Take your time. They are there to make the concepts clearer to you. In Module 007, we'll cover text editors and Linux process management, VI and Nano, then PS, Top, Hill, Jobs, BG, and FG. Before moving to Module 007, run man chmod on your EC tool, and about 10 minutes of reading will make permission sections very familiar. Also use the Kimo app and try to familiarize yourself with some of the things that we are going to cover. Morakosi, Melissa, thank you very well.